used to like the high numbers.
Yeah, you are. Five.
Could've got another answer.
All right, it's 0.1949.
Come on up.
So that's part where you got one.
Yeah.
Where are you trying?
To go to the bathroom. Okay, so we know that the average is 67 miles an hour. So we can write that as the average, and the standard deviation is 3.5. So we can write that. And if we draw a bell curve, 67, and then it talks about 70, which is on the right, and we're going faster than 70, so we shade in this right side. So we'd have 70 minus 67 over 3.5, which is equal to 0.857, which we rounded up to 0.86. And then if you look on your sheet, that's 0.8051, but you need to subtract that from 1 since it's on the right, which gives you 0.1949.
Nice, everybody agree? Michael, get a prize.
Can I take Triton's too, because I know what he wants?
Triton doesn't get a prize.
I guess we'll see what it is.
Do you always round up like that?
He's gonna be like, whoa, and I'll be like, you left, and he'll be like, yeah. That's how that's gonna go. No, you only round up if it needs to be round up. Like this one was 0.857, so it's round up. If it was 0.851, it'd be stay at 0.85.
Yeah, but how do you know you use the three numbers and
If it's 0.855, then it's halfway between. Then you find the average. If it's not halfway.
The only reason with the exactly half thing is because there are a few for confidence intervals and for testing that we end up using that with. For right now, you can assume that you're just always gonna round to the nearest hundredth. You went up here, Triton, but I'm not giving you a prize because you left. Yeah. Okay, a survey indicates that for each trip to the supermarket, shopper spends an average of,
30,
no, higher,
60,
less than 60,
45.
45. With a standard deviation of 12 minutes in each store, length of time spent in the store is normally distributed, represented by the variable X. Shopper enters the store. All right, I am going to be super nice, and I'm going to do A with you, and then we'll make B and C prizes for separate teams so that we can all win prizes, because obviously that's the most important part of this class. Hey,
How quickly do you think you could bring up a microphone?
Pretty quickly.
We have someone who is not going to go on anymore.
okay.
Yay! Can I steal him?
Yes,
Thank you.
I'll be back.
Someone who's what?
they're doing the middle school play right now for the school, and apparently somebody just quit.
wait, we're missing it?
No, they're for doing it for the middle school and the intermediate school. All the high schoolers aren't watching it, unless you want to go tonight to the play.
So is
Someone
Michael's acting
decided
now?
not to participate?
What?
So Michael's acting?
No, he's just setting up a microphone.
No, Michael's the.
So are they pre-recording it or what?
No, like, people are watching the play right now.
Oh.
Yeah. Probably stage fright or quit or maybe puking, fainting.
That would be horrible.
It happens.
Punishment.
Okay. All right. Probability that the shopper is in the store between 24 and 54 minutes. All right. So average is what, 45? So 24 is probably like way over here, and 54 is a little bit closer, maybe like about there. We want to go between. All right. So tell me the plan.
54 minus 45 over 12.
Okay. So 54 minus 45 over 12 is what? 0.75? Did I do that math right? Yep. And that's a z-score for the top range. Now what do we need to do?
Would
Yeah.
you have to, would you have to find the z-score for the lower range?
Yes.
So then you would take,
P.S. I am going to be nice to you, Triton.
Yeah.
Because now that Michael's gone, if you want to come here by yourself, you can also win a prize.
I suppose I could.
Mm-hmm. All right, so now we got 2 z-scores. So now what? How do you find the area between 2 z-scores? No.
No, oh, subtract them?
Once you do something,
Oh, yeah.
you got to look up the areas and then subtract the areas, yes. You can't subtract the z-scores themselves. You got to subtract the areas.
Why can't you?
If you subtract these two, it will be, so if you find the difference between these two, right, it'd be a different section of it, which isn't necessarily the same, because it's not like each section has the same amount in it, right? So if I look up 0.75,
My lord.
0.7734 and negative 1.75. Is 0.0401. I got 0.7333. You guys get the same thing I did? Now, the final thing you have to ask yourself, because it's sometimes really obvious, you know how like sometimes when you get lost in the math or you get lost in your calculator, that you don't realize that your answer is stupid? Anybody ever do that before? Where you're solving like a story problem and you're like, how many gallons are in a pool? And you're like, 0.6. And it's not 0.6 because it's a pool, right? Okay, look at this picture. Does this look like the amount that I shaded could be 73%? Yeah, okay, so we're probably right. But if I had shaded just this corner over here, would 73% make sense? That's why a picture helps so much on these problems. Okay? All right, try the next two with your partner. Triton, if you want to join another group, you can, or you can.
I can
Yeah, you can.
So, 30, so, like 39, so the, 39 minus 45 over, that should be, negative 0.5. And score. Point 3.85.
Oh, 8. I was gonna say that did not make sense.
Okay, and then the next one is pretty much, I think, is like similar to A.
Are you okay?
Just-
What happened?
She made the worst possible decision possible in drama. She peeked through the curtains before they started and got real stage.
Like a kid freaked out?
Yeah. So they needed a mic for somebody off stage to read the lines instead of her because she got sick.
Oh, like threw up or? Okay.
I
Was
think
it
so.
people out
I
there?
didn't see
Or
her. 'cause she-
fainted kind of thing.
Yeah, but she looked through the. Apparently, she looked through the curtains before they started.
Oh.
Was it a main character?
No.
No, it's definitely a thing, guys. I mean, like, I've had kids, like, collapse backstage. Being scared about something is a real problem.
Yeah, I'm supposed to
Oh,
be
I, so, for -1,